And now we're going to change the form of the information we're given. So this time we're told that the 0 is -1. And so what would the factor look like? The factor should look like x plus 1. So think of it like x equals -1. If we move the -1 forward, we should get an x plus 1 there. And so I want to confirm, or at least see what happens when I divide it by that x plus 1 factor. So I'm going to collect up all of my coefficients. So x cubed, x squared, x, and constant. Let's see, write down the coefficients of each of those variables. So 15, 14, -3, and -2. And I'm not going to change the sign for the 0 because that's what I'm trying to find f of -1 and see if I get a 0 out of that. Let's see, drop the 15, multiply, combine like terms, multiply, and we get 0. So we do get 0, which does mean that f of -1 is 0. So -1 is a 0, which is really nice because that's what they told us. Okay, so what we have so far then is we have our polynomial as x plus 1 times 15x squared minus x minus 2. And so our task is to factor that even further. Let's see. So again, if you need practice factoring, I would pause it and see if you can figure out what the numbers are. Let's try 5x and 3x. And, oh, okay, I can see 1. So if I multiply the 2 and the 3, I get a 6, and there's a 1 there. And I want that. I want the 6. Okay, so I want 5x minus 2 and 3x plus 1. Okay. And then I want to set each of my factors equal to 0 and solve, and I should get that my zeros are -1, 2/5, and -1/3. Okay, sort of a fun one once we understand one of the vocab words that they're throwing at us. So we're given this 4th degree polynomial, and we're told that 1 is a 0 with a multiplicity of 3. Okay, so multiplicity of 3 simply means that there are 3 roots of the same number. In other words, the factored form has an exponent of 3 attached to it. Anyway, so let's see. I'll show what I'm talking about here. So let's go x to the 4th, x cubed, x squared, x, and constant. 4, -9, 3, 5, and -3. And I'm going to check 1. Should get a 0 out of this because they told me a multiplicity of 3. So drop the 4, multiply. I get 4, which gives me -5, multiply. I get -2, multiply. I get 3, multiply, and I get 0, right? Okay, now, nice thing is I'm going to do it again. That's what multiplicity means, is that it goes in there multiple times. So drop the 4, multiply, multiply, and multiply. Okay, notice I got 0 again. And a multiplicity of 3 means I can do it again. So drop the 4. Let's see, multiply that, and we get -3. Positive 3. Multiply that, we get that. Okay. All right, so now I've kind of exhausted all of my 1s, but I do have 2 numbers left out of this whole thing. So the factored form for f of x is x minus 1. A multiplicity of 3 means that it again went in there 3 times. But what am I actually left with? Okay, so let's see if we can follow through the logic here. So when I divided out that first one, this became an x cubed. Divided again, that became an x squared. Did it a 3rd time, that became an x. So 4x plus 3 is the factored form, it's the remainder of that last synthetic division. And so my zeros in this case would be 1 and, if I solve for 4x plus 3, I get -3/4. Okay, so multiplicity, that's just, all that means is that it goes in there multiple times, and we can sort of take advantage of that to shortcut this out. So what if we're actually given the zeros and our job is to find the polynomial? So you have to imagine that in order to be a zero, we must have had factored form to begin with, and we ended up solving each of the factors and set it equal to 0 and solve, right? So we can kind of go backwards from here. So if I say x, break this up into its 4 little roots there, then if I bring it over into its factored form, that means x plus 4's got to equal 0, x plus 1's got to equal 0, well that's just x equals 0, and x minus 2 equals 0. Okay, so this polynomial in its factored form would be x plus 4 times x plus 1 times x minus 2. Okay, and again, this is the factored form of this. And we'll go through the actual original polynomial form in a moment here with at least one of these examples, but let's jump down to the next one. Next one is a polynomial of degree 3 with zeros 3/4, -1/2, and 5. So imagine that we had x equals 3/4, x equals -1/2, and x equals 5. Now, one form of this that we could do is I could just literally say x minus 3/4, x plus 1/2, and x minus 5. That technically, yeah, that does work. But we think of how many times when you factored you end up with a fraction, right? We normally don't ever see a factored form with a fraction like that. Normally we solved and a fraction showed up, right? So let me kind of show you how that technique works. So in this first factor, if I multiply both sides by 4, I get 4x equals 3. So 4x minus 3 equals 0. It's typically how we see that here. If I multiply both sides by 2, I get 2x plus 1 equals 0. And of course x minus 5 for the last one. And so you'll just be aware that you'll see both forms of it. So yes, I understand x minus 3/4 technically is factored form, but also 4x minus 3 is appropriate for that one. All right, and the last case, again, go back to the little multiplicity adventure there. Says we've got a polynomial of degree 3 with zeros 5 and -8, and 5 happens to have a multiplicity of 2. Okay, so technically that means 5 shows up twice. So in our polynomial, we have x minus 5 squared times x plus 8. Now, this is actually, you don't have to do this all the, well, let me rephrase this. On occasion, you'll be asked to multiply out and combine like terms. So I do want to show you that, but on occasion, factored form will actually be sufficient. So please follow directions and make sure you're aware of whether the goal is to end up with factored form or the simplified form. So in this case, I'll work out the simplified form for you. So p of x is x minus 5 times x minus 5 times x plus 8. And I'm just going to worry about those first two for right now. So that would be x squared minus 10x plus 25 times x plus 8. Okay, and now I want to multiply that x plus 8 in there. And I'm going to do this sort of a nice organized method here. I'm going to come over here so you can kind of see what I'm talking about. All right. Okay, so if I go x times x squared, I get x cubed. x times minus 10x, I get minus 10x squared. X times 25 is 25x. And then I'm going to, and I know I just wrote that in red, I'm going to do that in blue so you can see here. I'm going to line them up row by row so I can see like terms ahead of time. So 8 and x squared is positive 8x squared. 8 and negative 10x is minus 80x. And 8 and 25 is 200. And so the benefit of doing it this way is now I can see very quickly which like terms are like. So x cubed minus 2x squared minus 55x plus 200. That works. And so that's our polynomial. So p of x equals x cubed minus 2x squared minus 55x plus 200. And again, watch directions on something like this. I see a lot of students who get very excited about multiplying when factored form would be sufficient, and I see a lot of students who give me factored form without recognizing that, I do actually want to see if you can multiply it out and generate the full polynomial. And it's not like every question on a test will make you go this far, but it does let me see who's able to combine like terms and multiply correctly. So anyways, good luck on homework.